Thank you, Katarzyna. I can't speak so fast as Janusz, but I'll try to give a presentation on artificial intelligence. First, one thing, we are making two big mistakes when we discuss this. First mistake is that a lot of so-called artificial intelligence systems are not artificial intelligence systems. They are experts, they are great expert systems, they are great programs, but they are not doing what artificial intelligence is supposed to do. That's the first thing. The second thing is we are mixing two things. There are two artificial intelligence. One is general or generative artificial intelligence, and another is expert or applied artificial intelligence. Basically, the near future is applied expert systems, which in very narrow domain, they are able to do some intelligent things. General artificial intelligence, like we all hope that ChatGPT will provide something like that, we are still quite far from that. Despite appearances that ChatGPT is something, but it's nothing more than a statistical linguistic model which is calculating which words suits the best to your question. So that's where we are. And the third thing, I have no picture. I really like to have pictures. I have no picture. I don't know how AI looks like. I can provide millions of pictures of systems with AI embedded, but I have no picture of artificial intelligence. So let's just imagine that there is something in the chips or between the chips and the systems. Maybe you have heard of course you have heard for Alan Turing. He was the great expert working for UK at the end of the World War II, deciphering the German codes. Well, he was already dreaming about having a machine which could go back and forth in the memory and make some reasoning and make some conclusions and be able to override its initial instructions. So Turing was already dreaming about this. Today we don't have unified definition of artificial intelligence. There is no single, but basically we're trying to get what we already have with a human person. So ability to reason, ability to learn, discover meaning, solve problems, and including the ability to adapt to new circumstances. So this can be applied to civil AI systems and also to military AI systems. First known use of in armed forces was in United States in 2016. I really don't believe that this is first use, but it's first public use of a military system. This was a spy drone, simply used in training exercise. The drone was just received the task. The drone took off, did the task, decided how high it will be, and then landed. But of course, we are dealing. Artificial intelligence today is everywhere. Google and Amazon, they are using this. They're monitoring us, the customers. They are predicting our behaviors. You know, Cambridge Analytica, which used this probably not only in one elections, but in several elections, observing the needs of voters, preferences, and predicting the needs of voters. And the biggest shock actually two shocks were in 2016, when world grandmaster, world champion in chess was beaten by Deep Blue, and then also a world Go champion was beaten by DeepMind. So at that point we said, okay, this is not a joke anymore. But we are still, I hypothesized in my paper that there is a range of new possibilities to improve military activities, but there is also even more challenges. What we need to do, also in application and in regulation, is we need to strike a balance between opportunities and challenges. We don't want to get killed ourselves and our military units because one great AI system will just get crazy, and kill everybody there. We don't want to get there, so we need, also from the military perspective, very strong limits, and we need to strike a balance. It is, of course, a game-changing technology, and it's pretty much related to other technologies, like Janusz and some other people today talked about increasing of the power of computers. So. And Moore's law. So we basically see here a drastic increase in processing power, larger data sets, also increasing computational power. And AI will even improve that, and AI will be improved by that. And of course, all this is happening in open space. There is a lot of open data. And this is the place for advanced learning algorithms. This is what we want. This is what the systems want. So we shouldn't, now, again, to clarify one thing, we shouldn't consider AI as a weapon. AI is simply a set of code. AI is a code, is a computer program embedded in something. And it's pretty much like an enabler. It's like electricity, like combustion engine or internet. AI is not a weapon by itself. AI can use something to kill somebody, but not AI. And this is pretty much a difficult question now from the regulatory perspective, because how do you, I mean, you cannot really label AI as a weapon because it's a code. And even more, a bigger problem is, what if you use the same code to learn a car to drive, and you applied the same code to a tank? The difference is only that in the tank you have more sensors, it's more complicated, but it can be the same program. So how do you regulate that? That's a question for my colleague there. So in this debate, of course, AI is is part of a revolution in military affairs. We still don't know what this is, but it's going to be AI-based. And in the debate about AI, there is this conflict between boomers, enthusiasts on one hand, and doomers and deniers on the other hand. Boomers, they are, like, it's fascinating. They're fascinated. The war will change forever. The nature of the war will change forever, and this is definitely a revolution, and everybody will die, at the end because it's so great, So that's these boomers, enthusiasts. And then on the other hand are doomers or deniers. They're saying, yes, everybody will die. You will also die. We need to have this under control. We need to regulate this. And Europe caught itself in this trap, as I will explain later. But probably pragmatics will win because they say, look, it's just another new technology. It's great. It will enter armed forces in evolutionary manner. It's going to be tested, and that's it. Like all other technologies, like chemical weapons, like nuclear weapons. Ukrainians, they are using this to a much higher extent than any NATO country. I'll explain later, but for no use. They are not winning the war. So in Ukraine, they are using artificial intelligence in the targeting process. They are using a lot of sensors, like also from TikTok or from pinning the location or from a television image or from intelligence report. They can locate the targets. They can prioritize the targets. They can assess, which is more lucrative target and so on. And then at the end, the weapon on the ground gets the coordinate. And this can happen in 1 second or 2 seconds, even too fast for human mind to process. They are using application Kopriva on Android tablets, and Russians are much slower in this regard, but Ukrainians are not winning. Now, key element of artificial intelligence, as I said, is algorithm. Basically, it's machine learning. It needs data. Machine learning needs data. Millions of volumes of video or whatever, it needs data. And in military field, we have a problem because in all these exercises, there is a lot of data, but simply data is not enough integrated or it's secret, so secret that nobody can really take this data. But it needs data. The more data it has of different categories data, the better it is. Now I would just like to present briefly which are the fields of use of artificial intelligence, and then in the second part of my presentations I'd like to talk about a couple of challenges. So first use is in intelligence and surveillance. The idea here is to take data from different sensors to run supreme analytics and detect threats, suspicious activity, identify correlations, identify suspicious activities and unseen patterns, and also predict the trends from different categories of data. Video and text is the same now for the machine, should be the same. Intelligence services will benefit most from this, and the entire intelligence cycle, including dissemination of data. So data will come not only in human report, like in text, 2 pages, but also in machine version. And the problem is that this is going to come so fast that the human analytical person is going to be a gap here, a gap. I mean, it's going to be too slow. So this time is a problem. Then the second use is targeting by autonomous weapon systems. We already discussed this. Here, the point is to increase the speed, accuracy, and prioritization, and also to predict AI weapon, like AI loitering munition or drone will be able to predict countermeasures. So it will be able to, to avoid, not as it is programmed, but as it decides. Russians have nuclear autonomous system. Russian perimeter is basically a system which is able to launch a nuclear retaliatory strike if there is no contact with the Supreme Command. They even launch their command, they put their command into the rocket, which goes around Russia so that it's safe from the attack. So, and it is autonomous if there is no contact with the command. Then the next type of use is maneuvering and other actions by autonomous systems, where AI will take over tasks previously not taken by human, like time-consuming, boring tasks and so on. It will be used in patrolling, it will be used in convoys, in robotic air-to-air refueling, in drone flying. The modern thing now is swarms of drones. You have seen definitely this. Israelis have used this against Hamas. Swarms of drones in 2016. Sorry, in 2021. These swarms of drones will act as a single integrated weapon system. Very smart, very dangerous, adaptable, and so on. Talking about control and regulation, there are three. We use the term human-machine teaming. How much this system really is autonomous and how much human control there is. We can have human in the loop, meaning human decides. We can have human on the loop, meaning human decides only at some points. Like, here is prioritization of targets, and shall we shoot at this one? Yes, we shoot at this one, and it's execution. But then we have also human out of the loop. Human out of the loop means we have completely autonomous system, which, of course, can be already a problem. And then the last use I'll mention is cyber warfare. AI viruses, AI enabled attacks. So we can use AI offensively. Software will adapt according to defenses. Stuxnet, you probably have heard for Stuxnet. It's probably the first global AI system applied against Iran and their centrifuges. Remains of this program are still somewhere around, uncontrolled. Nobody knows. Deepfake videos and also false narrative news. And also defensively, we can use AI also defensively in the sense of identifying threats, vulnerabilities, early warning, and reacting. Basically, in the cyberspace, there will be AI algorithms fighting warfare against each other, offensive and defensive. If you think you will be able to defend your cyber systems without against AI attacks, without AI, you already lost. It's impossible. So many attacks, so adaptable attacks. There is no human who will be able to look 1 million of events per day. There is no way. So this is these are the systems. But then now coming to challenges. First challenges, and this is probably a regulative challenge. AI is going to be applied everywhere, also in military, in 5G, in 3D printing, in biotechnology, in cryptography, in hypersonic weapons, in directed energy weapons, and here you have all these fields. It's going to be difficult to regulate all these fields because we'll have to regulate also 3D printing, having in mind AI, not just AI. That's this complexity. Secondly, I focused more on geopolitical and strategic challenges. Now, AI is going to be perceived as a source of power, as a tool for power projection. And it's irresistible. It is irresistible. And there are two sets of concerns stemming from this. First set of concern is internal geopolitical concerns. Actually, AI revolution is happening out of governments. Governments are not in control. It's happening in companies and in academia. And this power, we have a Westphalian system, 1648, state is the key regulator on its territory. Now here, with this power, this is going to start slowly changing. And if you don't regulate that, we're probably already too late. But it's not within governments. Governments will be just buyers of these systems. You know? So that's one thing. But the second thing, which is even more problematic, is an external geopolitical aspect. We are already getting ourselves entangled into a kind of race to adopt AI arms race, which is zero-sum game. AI supremacy, and this is done especially between big powers, not the small countries like Slovenia or Croatia or whatever, but big powers, China, United States, Russia. For Russia and China, AI is a tool how to get USA under the throne, how to reduce their supremacy. For USA, AI is a mean how to retain their position. And actually, professionals from this field, they say that basically China has already surpassed United States in 30 key technologies, and it's just a matter of question when China will surpass United States completely. Putin spoke about this in 2017. He simply said the nation with leading edge in AI would be able to rule the world. So with this technology, right now, we are not cooperating, we are competing, actually. Of course, AI will proliferate asymmetrically. There will be actors with much more AI and actors with no AI. But still, assessments are that also smaller states, because the code, part of the code is going to be open, smaller states will also be in a position to get this. What worries us even more is that criminal groups and terrorists, the proliferation will not stop with criminal groups and terrorists or very smart individuals who can, create some problems later. So the last problem I would like to mention here is the secretive development. Right now, these companies are creating many things in secrecy. We don't have an overview, we don't know. And they are not sharing information. And this, in international relations, in the military international relations, this typically creates mistrust against each other, and we typically tend to overestimate the capacities of the other side. So we are getting into typical distrust dilemma with AI, just because it's perceived as such a big and powerful system. Situation in Europe is pretty much different from China and United States. We are investing much less. We are focusing, which looks good now from the perspective of this presentation. We are not focusing so much on development. We are focusing on how to ethically and legally, regulate this, because we are so worried. Because the point of the EU is to create an area of security, freedom, and human rights. So it's quite interesting. So we are losing here in this battleground against China and United States. We have adopted strategic compass in 2022, which just mentions artificial intelligence once. We have probably, Marko will speak about this a little bit more. We adopted a new AI Act just in December in 2023, which says first sentences are about the balance between innovation and and concerns, and the second sentence actually, or the second part, there is a big caveat mentioned here. All AI, EU AI regulation will not apply to military and defense and intelligence AI systems. So, ladies and gentlemen, welcome into an unlimited, I will not use the word, unlimited place where you can do whatever you want. So basically EU will regulate in a couple of months how AI should be produced and developed, but not in the military and defense field. So if you're right now a young programmer like I was with 18, I would just move there and this would be like a perfect heaven on earth because I could do whatever I want. This EU regulation also will not be valid in third countries and outside the scope of EU law. NATO is doing a little bit better. NATO adopted strategy in 2021, but also NATO is trying to use AI and is also financing a couple of projects is trying to use it to boost its collective defense capacity, crisis management capacity, and cooperative security capacities. But still, NATO focused quite a lot of time on the principles of responsible use. I'm going to focus on this in my next presentation, like in half a year from now. But this is the NATO. NATO did actually much more than EU in this regard. NATO also recognizes the risk of interference in allied AI. So if NATO will have AI systems, probably these systems will be targeted quite fast in any military conflict. And almost my last slide, these are the consequences of situation. So we are investing much less. We are in Europe. We are not cooperating. EU and NATO are not led on to this dancing floor. They are not led by the companies. And countries are protecting the companies like Germany, Fraunhofer, France, CEA. They're all developing these systems, but they don't share. We invest much less than China and USA. Our defense officials lack knowledge on AI, so when they are managing these projects, they are not sure exactly what is happening. There is lack of trust and a lot of data sharing problems, and yeah, it's fragmented. It's fragmented, and we're dealing with regulations. So this is the situation. For my conclusion, I would say it's going to be the same like with all major technological breakthroughs. First, there will be some uses. We will be all shocked, and then regulation will come like one step later, too late, but still better than nothing. So nothing new. We need, of course, to build not just national regulative system, AI regulative system, but international, even global, because if it's not global, AI system will simply go into the state where there is no regulation. So it will be, algorithm will be run from there and used somewhere else. So if it's not global, it doesn't make sense. Of course, Europe needs to be the first, is going to be the first. In this system, we need to include not only countries, also companies, like I said, defense industry, and programmers. If we don't have programmers there liable for something, we have nothing. We need to have a programmer. I'm speaking this as a former programmer. I was programming in 6 different languages, so if you don't have a programmer, you don't have nothing. Because you never know what is he going to do. We need to build the system around key risks. AI systems, if we are really opening the pipe completely, they're going to be unpredictable. So we need to build regulations around unpredictability, potential unpredictability. Next thing is proliferation. If we will face easy proliferation also to non-state actors, we need to stop this somehow with regulation. Dual-use nature, you already told a lot about this. Again, my question is for you or for everybody, what do you do with algorithm which is the same for driving a car and for driving a tank? What do you do? With whom, when, at which point? I don't know. I'm not a lawyer. Low trust among nations, basically we need to, because now France is hiding something in Europe and Germany probably also. There is some things are tested in the exercises, but it's NATO secrecy and things like that. And nobody knows exactly, or only a few people know exactly what is the result of this. This is going to cause low trust among nations, not only Russia, Europe, but also among Europe. So we need kind of confidence and security building measures like we have. You're probably not familiar with Vienna document. All weapons, major weapon systems possessed by states, they need to be declared to someone, and there are these inspections. How do you do that with algorithms? I don't know. But this is the solution we kind of know. We know this kind of solution. Okay. This is my thing. Thank you very much. I hope I was not long.